Hey everyone, how's the mood here? Are you excited? Are you already tired? Yeah, okay. Yeah, let's try that. Give a big shout out for the organizers for putting that. Perfect. Okay, that's better. Okay, so my topic today is how we can use the Angular CLI and a tool called Schematics to make our setup, library setup, and our life in general easier. But first things first, my name is Stanimira Vlaeva. I work for Progress, and I work on a very cool project called NativeScript. Basically, I'm taking care of NativeScript Angular, NativeScript Schematics, and the NativeScript Webpack plugin. And I'm also a Google developer expert for Angular and web technologies. And speaking of NativeScript, just a very brief introduction what it is. It's a framework for building mobile apps for Android and iOS by using web technologies such as pure JavaScript or something more sophisticated such as Vue or Angular. And as I said, I've been working on the integration between NativeScript and Angular for kind of the past 2-3 years now. And we have come a long way. And currently, we provide an option to have a single project, and you can have multiple apps inside it. You can have Android and iOS apps with NativeScript and also an Angular web app. So the whole idea is that you can share a really large amount of the code. But yeah, let's see what it takes to add NativeScript, like add a mobile app to your existing Angular app. First, we probably have to install NativeScript Angular. Then you have to install the NativeScript Webpack plugin for building. Then you have to update the package.json to kind of adjust a few things. Then you have to update the angular.json to introduce the new kind of project. Then you have to add a TypeScript configuration for mobile and an entry module, and then a root engine module, and then a new bootstrap component, and so on and so on. And it's not a thing that you'd want to do like in your free time. So that's why we decided to use ng-add and make that setup easier. In short, what is ng-add? It's a command provided by the Angular CLI, which allows you to extend your library, your package, shipped to NPM, with some setup scripts. And the idea is that ng-add will execute the setup scripts in every project that installs your library. Let's see that in practice. So we created a plugin called NativeScript Schematics. And what happens when you ng-add that to a web project? Well, first, obviously, the package is installed from NPM or whatever registry you have set up. And then some project transformations are executed inside your project. And here is how the output looks like. So first, the npm install, obviously, and then some files are created and some other files are updated. And basically, the whole setup that we saw 2 slides earlier happens automatically when you ng-add that package. And that kind of lock out there may look familiar to you because the project transformations that are used are happening with a tool called Schematics. And Schematics is used by the Angular CLI not only for the ng-add command, but also for ng-generate and ng-new, and every command that has to do something with scaffolding 2 files or updating some other files. So Schematics, we can say that it's like one of the key parts of the Angular CLI, but it can also be used as a standalone project, and you can also use it in your libraries or whatever packages you build so that you can provide a setup for the people to use. And in short, yeah, Schematics is it's the JavaScript library, first of all, and it's a tool for scaffolding, updating files, and executing tasks. And let's see that again, ng-add whatever package. First, we have npm install. That is some task that is being executed. Then we have scaffolding. Some files are created. And then something that's different from Yeoman or some other code generation tools, we can also update files. And for ng-generate, under the hood, Angular does quite a similar thing. It generates some files based on parameters that you provide, and it also updates files to register, for example, the new component here. Cool, but why should we care about schematics? Okay, so why don't we use just bash scripts or whatever if we need to create some setup? And to be fair, this thing that I described that we do in NativeScript, it can be done with a post-install script that uses just fs from Node and does everything here. But the benefits that we get from schematics are quite important. And the first of them is the atomic updates. So let's see an example. And this is an example without schematics. For example, you're just using the fs module from Node. We want to modify the package.json file. Fs read, change some content, then write the file. And obviously, the file is modified. Then we decide to do another change as part of that, that setup. For example, we want to create a file in the source folder called app.module.ts. And as you can see here, we will get an error because that file already exists. But what happened to the package.json? Well, it is modified. So kind of half of our setup worked, but not all of it. And we're in some weird state of the project where, I mean, the thing that we wanted to set up is not set up, but still we have changes, and our project may be kind of broken at that point because we're not sure. And we may try to create some roll-up or, I don't know, rollback mechanism to undo the changes, but still it's a lot of manual work to make sure this thing is transactional, right? And if you use schematics, you're basically working on an abstraction of the file system. So you're not directly modifying the file system, but what happens? We try to modify the package.json file. This creates an action in schematics. Then we try to create the app module file. This is another action in schematics. And the thing is that before applying all these actions to the real file system, schematics validates all these actions. And we will get an error earlier. Schematics will see that creating the app module will throw an error because it's not possible, and the package.json won't be modified. So the whole setup will fail, and it's going to be a kind of a transaction. So that's the cool part about schematics. It provides atomic updates. Other things that I like is that the schematics are composable. So you can use different schematics written by different library authors, including the Angular default schematics for generating components and services. You can use these. Another thing is that they're pretty easy to unit test because, again, you're working on an abstraction of the file system. So you don't have to write files in order to see that something is working. And the final thing is that you use TypeScript to define them. So it's not some JSON schema or whatever, it's actual code that you write, and it's pretty cool. All right, another thing. What are the schematic collections? So a schematic collection is a package that provides different setup scripts, let's call them like that. The default one that the Angular CLI uses is add schematic/Angular. And different setup scripts inside it are the script for generating a component, script for generating a service, and engine module, and so on and so on. But of course, there are another different collections that you can use in your Angular project. For example, there are the nginx schematics, and of course, the NativeScript schematics that I already mentioned, and we saw in the previous talk the Apollo Angular schematics. So basically, any library out there can have its own collection. All right, how do we create a collection? The easiest way is to use the schematic CLI. You can install it globally like this, and then you can use it with that command to generate a new collection. What's inside the collection? Not too many things, honestly. We have some package scripts like the package.json, the TypeScript configuration, and some other things. And of course, we have the actual collection code. And for now, we're going to focus on the collection, the package.json. Okay, the package.json, we have a very important property here called Schematics, and it points to some JSON file. This is very important, and if you use schematics for ng-add or ng-update in your library, you need to have that property in your package.json. So what's inside the collection JSON? It's just a description of we decided to call them scripts, so schematic scripts. And here we have, okay, let's go back. We have my collection. This is just one schematic script. And we have a factory for it. This is pointing to another file in the source. And that file here, my collection index.js, has a function. And in order to explain that function, which looks kind of weird, it's a function that returns some tree and so on. Let's take a break and talk about schematics theory for a second. Cool. What is a tree for schematics? It consists of two parts. The first part is the base. You can think of it as the actual file system that you're taking, like the current directory that you're in. This is the base for your tree. It contains all the files in your project, for example. And then you have certain actions. So these are the modifications that you're going to apply to the base. And there is another term here. There are a lot of terms in schematics, but you get used to it when you start actually using them. So don't be afraid if you don't remember like half of the things that they talk about. It's totally fine. And I'm sure there's a lot of information. So a rule. A rule is a function which takes a tree and returns another tree. And the trick here is that the new tree that's returned by the rule, it has some new actions applied. And what is a rule factory? Well, it's a function that returns a rule. So basically, it's a function which returns a function which accepts a tree and returns another tree. Is that clear? Okay, cool. That's good. I hope there are like no rule factories. Yeah, we'll stop here. So back on our code, we have the rule, which is this function that accepts a tree and returns another tree, in this case, the same tree. And the wrapper function is the rule factory. So basically, in order to define a setup script for schematics, you need a rule factory. All right, how do we develop stuff with the newly generated collection? First, you need an npm install, clearly, and then, because it's TypeScript, you need to transpile your code, and I'm just running, usually, the TypeScript compiler in watch mode, so I can see the errors and develop and so on. So this is the most basic thing you need to get started. After that, how do we execute schematics through the schematics CLI? We need to use the keyword schematics. The dot here points to, obviously, the current directory, but it can also point to another schematic collection. But currently, yeah, we're going to execute schematics in our newly generated collection. So it's going to be just dot. Then we have colon, and the thing after the colon is the name of the script. So I'll go back very quickly just to remind you, okay, of the collection JSON, because that's very important. So once again, we have the factory here. Okay, that's pointing to our function. And the key is my collection. So this is the name of the schematic, the setup script. Cool. Let's go back. Okay, so when we run the command schematics dot colon the name of the script, my collection, basically nothing happens because we didn't do anything. We just got a tree and returned another tree. All right, how do we do stuff with schematics? First, logging. It's very easy. We need to provide another option to the factory. So the factory accepts a tree, and it can also accept the current context or whatever. And the context contains a logger. And the logger is basically built-in schematics. And you can log stuff. That's it. So yeah, we have context logger info and some string. And then, of course, we need to register that in the collection JSON. And yeah, of course, this is pointing to our factory function. And this is the name of the schematic. So when we execute it, we will get some log. And nothing else happens. So basically, that is the logging part of it. Okay, how do we provide options, like arguments? For example, when you use ng-generate component, you should provide the name of the component. So we can also do that in our customly generated schematics by providing options to the rule factory. Not the rule itself, but the rule factory. And then when we execute that, we can provide the options as arguments to the command. And you can see here we are providing --name, and that's accessible through the options object, and we can use it inside the rule. Creating files, pretty easy. Tree.create, we need to provide the path to the file. That's the first argument, and the second argument is the content. And what happens when we run it, we create something. Renaming and moving is very easy as well. We have tree.rename, another built-in function in the tree. We provide the old path and the new path, and pretty much that's it. And also, it's not just for renaming, but also for moving files. So if you provide the second argument to be an absolutely different path, this will move the file. All right, we covered the basics. We have how we can do logging, we can provide options, we can create files and rename files. You can also delete files with another built-in function that I'm not going to show because it's straightforward to use. And yeah, you can move files. And the really cool stuff that I'm going to show you, and we may not be able to cover all of that because it's just too much stuff, but I will give you some links that you can check out later, and you'll see how you can use all these things. So first, how to compose different scripts, how to do templating, how do you modify actual files, and of course, how to do unit testing, which I should probably put in the first place. I don't know why it always happens like that, just testing at the end. It just happened. It's not intentional, like really. Yeah, I just remember that, yeah, I have this sample repo with schematics that they prepared, and I don't have tests there, but it wasn't intentional, right? All right, composition of schematics. You remember this logging script that we saw earlier? We registered that in the collection JSON. So again, we have the factory, and then basically the name of the script is logging. So in some other schematic or some other script, we can use the schematic rule, which is provided by Angular dev kit/schematics. And by using the schematic rule, we can provide as the first argument the name of the schematic that should be executed, and as a second argument, some options. So yeah, this is it's not a rule, it's a rule factory that is provided it's built in the Angular dev kit schematics package. There's so much schematics, so many things are called schematics here, I'm sorry. So yeah, this is a rule factory. And basically we can use it to invoke other scripts. Is that clear? I think it is. Cool. All right, a little bit on rule factories. Yeah, just a reminder, rule factory is a function that returns a rule. And a rule is a function which returns a tree. And this may be a little bit confusing here because we're not providing any tree to this rule factory. But this is very important to get when you first start whatever trying to do with schematics, that usually if you don't have to provide the tree as an argument, it's using the base tree. So if you're running this script in some directory, the tree that will be used will be the tree of the current directory and all inner subdirectories. And yeah, it's probably not the most common thing you will do in the beginning, but it's important to know that if you're running the schematic in some folder that contains node modules, it's probably not the best idea to traverse all the files in the tree. All right. So, not like it happened to me, but okay, it did happen. So, simple composition, we get the same result as when we were running the logging schematic. That's not really a composition because we're just using one script. So to compose things, it kind of requires more than one thing to be composed. Anyway, so how do we actually compose schematics? There is another built-in rule factory called chain. So in chain, we can provide an array with multiple rules, and then they will be executed one after the other. And here we get the same result. We log something, and then the second rule that is inserted there, the second arrow function, creates some file. This is another common pattern. So you may have to combine different scripts with chain. All right, templating. First, how does the template look like? Has anyone bothered to use, what was it, EJS? It's kind of a thing for templating. I haven't used it either. I just, people told me that it's similar. No, I'm kidding. So, in the source code of schematics where the templating thing is implemented, it says that it's very similar to EJS and it's using the same algorithm for templating. That's why I was wondering if anyone ever used EJS. Anyway, so the template, how does it look like? Here I have just a single folder called files. And the folder has a single file called __ file name and 2 more underscores. And this is a special whatever syntax. So when you have 2 underscores, file name, and 2 more underscores, it means that this file name thing is some variable that will be interpolated when you execute the template. And we can also have content evaluation. So again, this is some special syntax with the left arrow and ampersand and so on. You get the syntax. And we can also have content interpolation and a few other things, but these are the more important ones. So this is how a template looks like. And yeah, basically, once again, file name and cd here can be provided as arguments to the template. All right, how do we use the template? It's very simple. It's this thing. I'm not even gonna comment that code because when I first saw it, that was my reaction. And that was my reaction, honestly, for a long time when I saw this template thing. So what I used to do is just copy it whenever I have to use it. But then I spent some time, like yesterday, to understand how it works. I'm kidding, maybe. So, theory time again. Remember, we have rules. It's a function which takes a tree and returns another tree. We also have sources, which are functions which don't take anything. I mean, it can take some stuff and returns a tree. So the idea is that you basically create trees out of nothing, but not exactly. So just a quick note here, the source can take the current schematic context, but we're not going to focus on that. Just think about it as a function that creates a tree out of nothing. And we also have source factories. Loaded, right. And yeah, we need an example for that. For example, a source factory is the function URL, which is provided, again, by the library Schematics. So when we provide URL and some path, what happens is that we get a source, basically a function that will return a tree, and that source, when we kind of invoke it to get the actual tree, it will contain actions. So not the base, but actions for creating every single file in that directory. So this is another minor difference between source and row. The tree that's returned here, specifically from that source factory, doesn't have a base. It has only actions. So we basically need a real tree that we can apply the source to, and that way we will get the final resulting tree. We'll see that in a minute. Okay, this is the refactored code from before. So first, we have the URL source. This will create actions for create every single file in the files directory. Then we have the template rule. When we apply that rule to some tree, it will interpolate and evaluate all the functions that we saw earlier. And then we have the template source. So we provide the URL source. Basically, we take every file in the files directory, and with the apply function, we apply all these rules to the files in the files directory. Okay? Kind of? Okay. So yeah, just once again, the URL source, we have the files with the underscores and the raw content. And when we apply the template rule to these files, we actually get the final output files, because we provide variables, and these variables are replaced inside the template. So we have the template source, and then we merge that with the base tree by using the merge with function. And then we just return the merged tree. And another quick note here, you can have different merging strategies. So you may want to overwrite files, you may want overwriting files to throw an error. You can also have just overwriting of the content of some files. There are different merging strategies, anything you may need. So check this out if you have to do templating. Because yeah, it's important to handle different situations, especially if your library creates new files in the project of the user. It's very important to handle situations where these files may already exist. So you don't want to overwrite the existing files. And if we run the template schematic, we basically create some file, and the file is interpolated. Another note here, if you're using the schematics CLI, the schematics keyword that we use here, you need to provide debug false so that you actually execute the files, the actions on the file system, because otherwise they won't be executed. All right, let's do some coding. How much time do I have? Does anyone have any idea? Oh, I have so much time. All right. So what we're going to do is try to edit a file. And okay, another important thing about ng-add, if you ng-add some library, the library will be installed, but it won't be saved in the package.json file. So if you're trying to create a setup script for ng-adding, you will have to usually modify the package.json in the project and save your library as a dependency or development dependency or anything you would like. So let's see how we can do that. I think I have it set up, editing, whatever. So I'm just gonna delete everything and let's write that from the beginning. So as options, we accept the name of the library and the version of the library. And we want to save that as a dependency in the package.json. So what we need to do is, first, we need to get the package.json file. And let's say that I'm going to execute that always in the root of the project. So this will be the path for the package.json. I can read that from the tree, but this will actually return a buffer. So it won't be an actual string. So I probably have to convert the content from a buffer to a string. And also, I'm not always sure that this file exists. So this buffer here may be empty or maybe just no, because the function here returns either a buffer or no if the file doesn't exist. So let's prevent some unfortunate things from happening and just throw an error. And there is a special class for throwing schematic errors, which is called schematic, what was it? Schematic exception. And we can say cannot read the file at that path. Cool. And we have the content here. But the content, what is it, the content? We have a buffer, and buffer to string returns a string. And the package.json is a JSON object, and we obviously want that to be a JavaScript object. So we, again, need to parse that. So let's call that JSON, for example, and call JSON parse content. And this may also cause some problems. So the only way I know how to prevent JSON parse errors is by using try catch. Honestly, I know that JSON parse will throw an exception if it can't parse the string. So I can just catch it. And here I can use the context logger and log that I couldn't parse the file at that location, package.json path, cool. And then I can just rethrow the error. And obviously this won't work, so I have to extract that variable here. Okay, we have the package.json content, finally, as an object. So what we can do is, yeah, you saw earlier that the name and the version of the library are inside the options object. So we can just fetch them from there. Name, version. Get it from options. Pretty cool. And then we can assign that as a new dependency in the JSON file. Yep, simple enough. Of course, we may check if there is such a dependency already, and we may not want to override it, but this will do for now. Another thing, am I missing something here? Like on this line of code, there is some problem. Come on, anyone? What may be an issue here? Okay, it may be an issue if I don't have dependencies inside that object. So if okay, the right way to do it is not that, but I don't care. So if we don't have dependencies, we may as well just create an empty object for dependencies. Fair enough, right? Yeah, obviously you can use object has own property, but it doesn't matter. All right, we have the new content inside that JSON object. If I wanted to be super fancy, I may have created the new a new variable here instead of mutating this one, but let's not go there. So we can have the new content by just stringifying that object. So we can use JSON stringify, JSON, awesome names. And then what we need to do to create an action for overriding is use the tree.override function. We need to specify the path. This is the same path as before. And we need to specify the content. And then, of course, we need to return the tree. That's very important because if the rule doesn't return a tree, nothing will happen. Okay, so this is how you can read files from the tree, modify them, and then override them. And let's see if it works. What was it? So schematics. So this schematics is already registered, so I'm gonna see how it's called. Editing something. Okay, this is the factory. So it's called add dependency. So this is the command I need to execute. So schematics.add dependency. I need to provide the name, which is gonna be Amsterdam, for example. And then the version, which is gonna be awesome. And that should have updated the package JSON. But nothing is happening because, as I said, you need to provide debug false to actually apply the changes. Okay, debug false, the file is modified finally. Let's see what's the difference. Yay, great success. We actually have Amsterdam also. And I'm just gonna check out all these changes. And let's go back. This project is already in GitHub, so if you want to see it, it's called Schematic Samples. It contains all the examples that we saw here and a few others that we didn't have time to cover. Also, I really recommend this blog post by Manfred Steyer, who we will see on the stage later. These are the kind of unofficial documentation for schematics because there is no such thing. And if you want to see more complex stuff, you can check out the Nearscript schematics library and file bugs because I'm sure there are many of them. And that's it. Thank you so much. Thank you. Yep. Should I go? Yeah, I guess. Bye.
Does anyone have any questions?
Oh, yeah, questions. Sure.
Hi, I think the template you mentioned is the Eclipse modeling framework, template syntax.
Okay.
What was especially nice about EMF is that you can generate code, which you can do here with schematics.
Yeah.
But that you could also use your domain model to generate code and have code in the same file manually modified. So your next generation cycle would keep your manual coded audit in the same file.
Nice, that sounds cool.
That's the problem with the generating stuff.
Yeah.
I wonder if that's possible with this schematics thing. I mean, can you leave parts of a file intact, regenerate other parts, and then in that way enhance your application by just changing your model and regenerate it? I mean, I think that's part of the goal you also want to achieve.
Yeah, so that is a problem. I haven't thought about how to fix it with the templates, but what I usually do if I have to modify files or regenerate files is read the content of the file and check if it's already valid, for example, instead of regenerating it. A very good example is, yeah? Yeah, no, I haven't thought about that example in particular. But if I, for example, have ng-add registering a module inside the app module, if I run it twice, my kind of check is just reading the file and seeing if that thing I'm trying to import is not already imported. So yeah, but that's a good point, and thanks for the question. Yeah.
One last question. Hello. Do you have any experience with other frameworks like Vue or React and using schematics?
I'm not sure. Okay, I'm kind of sure that Vue or React doesn't use schematics. Actually, there is some schematics library for React, and one framework that I'm sure that uses schematics is nuxt.js, if you're familiar with it. The Nest COI actually uses the schematics runner, or basically uses the Angular COI under the hood to execute schematics. And they also have their own collection to generate Nest-specific things. So yeah, but yeah, the cool thing about schematic is that it's completely platform agnostic, and you can use it for any kind of generation. Yep.
Wonderful. Well, thank you, Stanimira. Wonderful talk.
Thanks.